Okay, who's ready for part 5? As I've done with the last part, I added a few things there, as you probably noticed by now, and I'm doing the same here. Regular expressions. Though a big topic, we can probably touch on it and start having a look at some basic regex syntax. So let's make a test file. Going to keep this very simple. Let's have a look at our file. And let's do a very simple grep command. Okay, so we see that wherever the number 1 is appearing, grep is grepped. Remember the difference between single and double quotes. In this case, it doesn't matter because we're not using variables yet. But notice that we could do something like search string is 1. Now, this means a completely new command. So it's not some sort of piping or redirection. We're just going to execute a completely new command. And sure enough, this works. So we're looking for search string as a variable, and we've set this variable to look for 1. If we change our variable, now we're searching for 2. You can notice how the syntax per line can get longer and more complex. Sometimes lines take a few minutes to decode, especially when regex is involved. And as we've seen in the previous part, or in one of the previous parts, replacing this by single quotes means that this is now literal text, and so we're no longer looking for whatever this variable has translated to, but we're looking for this text, which of course isn't there. Let's try something else. We're going to look for the text one, as we did before. Let me just remove this. And we're going to specify that whenever you find this, give me the line before, one line before as well. So now grep is kindly for us split it up and say, okay, I found this 11 here, and just a line before that, B1, I found this. The same here, 1, the red matches the search, and just before that I found this. Very handy, this output format, because we can see exactly what's happening. We can also do after instead of before. So the 1 is found, and the 2 is outputted. The 1 is found, and the 2 is outputted. We can do all sorts of fun things. 2 lines before, 2 lines after, etc., etc. We can also say, as soon as you find even just one match, stop straight away. Okay, so it finds the match, and it doesn't continue looking. It just stops straight away. Or, find me 2 matches. Let's add 1, 1, 1, and confirm. Indeed, we don't see the 1, 1, 1 because 2 matches were already found. Okay, let's have a look at the file again. How about if we look for the term A? It's not there, because all these are lowercase. So we can search case insensitive. Case insensitive finds us exactly what we're looking for. Again, all of these can be combined. There's nothing before A, but there's something after it. Notice how grep and bash allow us to specify the short options straight after each other. Makes it very handy. Now, if we want to search for multiple terms that are not the same, we can use grep. We can search case insensitive for the text B, and we also want to see lines that have 22 in them. Sure enough, that works. Or we look for C, any line that has 1 in it, any line that has 2 in it. And again, this works. 1, 2, 1, 2, and C. Now, if we have a binary file, or a file which has non-ASCII characters in it, we might want to scan through such files as well. In this case, even though our file in this case doesn't have that problem, or that feature, we can search like this. If this were a binary file and it had, for instance, non-ASCII characters in it from other languages around the world, and we would have used this particular way of searching, then any ASCII text that would still be found would be displayed correctly. If we hadn't specified this, our output might have looked mangled up, or more mangled up than if we would have specified this. Okay, so this is all very straightforward. Now let us introduce a little bit of regular expressions. For this, we'll edit our file and make a few new additions. Okay, so let us look for some text A. Sure enough, we have some output there and it searches for the text A. Now, we want to look for an A only at the beginning. So what we're saying here is we're literally writing, we start at the beginning, then you should see an A. So this A no longer qualifies because it's not at the beginning. Let's look at the C example. C versus C. Now we only see the lines that start with a C. We can do something similar by looking for, let's take our C example, which shows 2 lines. But we're going to look, let's search case insensitive for C, which gives all these results. And we're going to look for a line that has the letter C, and then straight away the N should follow. So here we were looking for, we should straight away see the start and then some other text, and indeed that worked. Now we're going to look for a text, and then straight away the N should follow. So this one should qualify, but not this one. And indeed, this one qualifies, and you can see how grep knows, yep, that's the last character, and straight away we have the end of our line. How about if we want to look for 2 characters, C and B? Great, that works. So we can specify between square brackets that we're looking for 2 characters. How about if we want to look for a B followed by an E? Now, if I would search like this, of course, this string would not qualify. But I can say, in between B and E, there can be 2 different characters. So I use dot dot. Dot dot tells grep that it should interpret it as any character. Any character in these cases would be C and D. But any character can do. And indeed it finds it. Note that what it's searching for, any character, is indeed part of what it finds. Also, have a look at this example and notice something very special. Here we're using single quotes, yet grep interprets this not as variables, but as special search syntax. So be aware that even though we saw that these single quotes do not interpret variables, they will still, for example, grep, interpret specific regular expression search commands. Another way of saying, look for any number of characters as long as you find B and then E somewhere. And this works too. Now, we're going to use this syntax. \+. The difference between these two is that this one will look for any number of characters. This one means one or more. So let's say if we can produce the difference between the two. BC. And we're going to say any number of characters may be in between. Sure enough, it finds it because there's 0 characters in between. How about if we say at least 1 character? And indeed, it fails or it works because there is no character in between. If we were looking for B to D, it would now work because there's at least 1 character in between. And of course, the same would work for 0 or more. So remember asterisk as 0.more or \+ as at least 1, which is a very handy difference to know. We can also use ranges, A to Z, or 0 to 9. Remember that we can also say at least 1. How about if we do something more complex and say this? This means one number from 0 to 9 and another number from 0 to 9, at least one of them. Maybe not exactly the best way of writing things, but you get the idea. 1 to 5, this works too. Or x to y, there's no x to y's. A to B. Now notice that because we're searching case insensitive, it's finding the uppercase a's too. Let's remove this, and it will only find the lowercase ones. But we can expand our search range like this, and now it will find the uppercase ones as well. We can even say 0 to 9. And you can see how very powerful search strings can be used. We can say search for this. Now, why does it give only these results? Well, let's look. Start at the beginning, one particular character, and end at the end. Straightforward. We can also use special quantifiers. Yes, I need to specify this as follows. So we're looking for any alphanumeric, character, not alphanumeric. This is a little bit different from our TR example, where we can, for instance, TR, and remember that with TR normally we can specify only one character, but in this case we can use this special syntax, regex syntax, to do the following. And notice how it's deleted any alpha characters, leaving the numeric ones. So in this case here we use single brackets. So in summary, we've seen how we can use regular expressions, we've seen how we can use grep with some lines after, with some lines before, with just a number of matches, 1, 2, or 3 matches. Case insensitive, we've seen how we can use egrep with the OR option so that we can look for multiple strings. We can also search for various items using the brackets, and start and end we've seen. Notice that we can, for instance, also do something like this. Grep minus v, start end. So what we're saying here, the minus v, and we haven't seen that one yet, is exclude anything. So we're this time not looking for something that matches, but we're going to exclude something that matches. And what will we exclude? Well, any line that straight away starts and straight away ends. Indeed, empty lines. And sure enough, our empty lines are gone because we filtered them out. Another example of minus v. Exclude any lines with 1 in them. And sure enough, any lines with one in them are gone. We've also seen how we could use the binary files as text option, and how we can use special quantifiers with tr or with grep. All these are available online, and you can go and have a look for them. So this was a basic introduction to regular expressions and an introduction to grep. See you in the next part.